The brown coloration of healthy coral is due to microscopic algae called zooxanthellae that live within its tissue. The coral has a special relationship with these algae called symbiosis. The coral acquires food from the algae, and the algae receives nutrients and a safe place to live. However, if the water temperature rises, corals become stressed, and this relationship begins to break down. The zooxanthellae cells begin to die or leave the coral tissue. Without its resident zooxanthellae, the polyp tissue is transparent and the white limestone skeleton beneath becomes visible. This process is called bleaching. The coral polyps, now a ghostly white, are still alive. If normal temperatures return in time, they can recover their symbiotic algae and return to health. However, if the water remains too warm for several weeks, the polyps eventually die. Within a few days, the dead coral skeleton becomes coated in plants, like algae, that move in to fill the space. If stressful conditions, such as high water temperatures, occur over large areas, the reef may experience a mass bleaching event. In 1997 to 98, reefs around the world experienced a major mass bleaching event, coinciding with high sea surface temperatures. Approximately 65% of reefs in the Great Barrier Reef Marine Park were affected during this time. Most reefs survived, with relatively low levels of coral death, while some locations suffered severe damage with up to 90% of corals killed. Full recovery of badly damaged reefs will take many years. Corals and reefs are, to some extent, resilient to the impacts of coral bleaching events. However, if coral reefs are continually subjected to the impacts of severe bleaching and other disturbances, their resilience or ability to recover will diminish.